presentation has titled Multidisciplinary Applications of Robotic Solutions in Shallow Coastal Environments. And we will have joint presenters. We will have Francesca and Fantina from CNR-ISMAR Italy. Please.
Thank you very much. So good morning, everybody, and thank you for the invitation. It's a very nice event. I'm Francesca De Pascalis. I'm from the CNR-ISMAR in Venice, and she's Fantina Madricardo. We are researchers at ISMAR CNR, and I'm personally I'm expert on the hydrodynamic models, and Fantina, she's a geophysicist, and she's an expert in acoustic surveys and acoustic processing of the data. So we are from CNR-ISMAR, and this is the Institute of Marine Science, and we are based in Venice. And CNR is the largest public institution for research, marine research in Italy. Today we would like to show you some multidisciplinary applications. Sorry, it's working, yes. Of robotic solution in shallow coastal waters and coastal environments. So probably you already know that the coastal environments are the 20% of the Earth's surface, and more than 50% of the human populations lives there. We have also the 70% of the largest cities located in the coastal areas, and these environments are very, very highly dynamic, and also they are affected by multiple processes. This is the main features of this environment is the variability. So these processes are induced by natural changes, so the natural climate change, let's say, and also the anthropogenic activities. Why monitor these environments is important? Because the shallow coastal and transitional environment in particular are highly productive places. So we have not only a lot of production in terms of fisheries or food, but we have many, let's say, ecosystem services. So monitor and manage this rightly, these kind of environments is crucial for the human well-being, let's say. So in this presentation, we would like to focus on the transitional environments. In terms of, these are defined as the environments where the influence of freshwater and marine water is highly detectable. So we can see directly the influence of the freshwater in the marine environment and vice versa. And speaking of, let's say, the monitoring challenges connected to also the robotic application, I think, in these environments, we can let's say, list here some environment characteristics and some examples, of course, of the possible connected problems in monitoring. So here we have that, for example, we have strong density gradient. This can lead to some problem in the systems that are based on the buoyancy, for example, the AUV. Or the extremely shallow waters that it can lead to the difficulty to reach some areas, and also we have a time-consuming monitoring. Then we have turbidity, so a lot of problems in optical systems. Strong hydrodynamic and single events. This is, for example, the floods. In Venice, we have the high water, you know, and also we have, for example, the floods in the rivers. So if you have instruments deployed there, during this kind of events, you can lose them. And also strong biological activity, so you have to think about how much time you want to deploy your instrument, because fouling can be an issue. And also, there is a difficult to detect some kind of object, because during one of our projects we have difficulties because we were monitoring the ghost fish net, and when they are on rocky seabed, substrate, you have a lot of biological activities there, and you cannot recognize them anymore. So, at least acoustically, for example. And there is also the presence of a lot of obstacles. In Venice Lagoon, we have a lot of traffic, boats, public transports, whatever. So, unmanned vehicle can have to be really, and the navigation, the control system have to be really, let's say, strong and well designed. So the main feature, as I already told you, is the high variability of the system. So there is a more difficult synoptic view. So to monitor the deep ocean, or we need less sensors, let's say, because the variability is not so high. Or at least we can assume that a big portion of the sea have the same characteristics in such way. But here is not like this. The variability, the spatial variability, but also the temporal variability is really high. We would like to present you today some application in the Venice Lagoon. So we give you some context, and the Venice Lagoon is the largest lagoon in the Mediterranean Sea, and it communicates with the Adriatic through 3 inlets, so the Lido in the northern part, Malamocco and Chioggia Inlet. The typical morphological features are navigation channels, tidal flats, intertidal areas, and salt marshes. And it's a very, very shallow area, because only the main navigational channels are deep. The rest of the lagoon is more or less 1.5 meter, so it's very, very shallow. Sorry, I skipped one, I think. Yes. The lagoon is also in rapid evolution. So we, in the last century, we lost the 50% of the salt marshes, also because of the human activity. And we have a deepening trend in some part of the lagoon, especially the central one, the central and the southern one. Another point is that we have high water, you know that. You probably read about that on the newspaper. And we have now, the MOSE project is started to work. Not always, but started to work. It's a system of mobile barriers at the inlets, at the 3 inlets that you saw in the previous picture, and this should avoid the high water to enter into the lagoon. So on the base of the hydrodynamic and meteorological forecasts, they decided to raise up these barriers to protect the historical city of Venice from the high water. So, and we have also the impact of the large ship traffic inside the lagoon. Of course, during the pandemic, we didn't have these large ships enter into the lagoon, but you can see how big there are in comparison to the buildings. So, and the effect can be very, very dramatic. Also, if you look at the wave that at the wave that the ship produce, here you can see that in 30 years we lose a lot of the tidal flat and the salt marsh in this area. So in 30 years we lose a very, very large area of these.
More than 100
Yeah.
more than 100 meters
Yes.
in 30 years.
And so now I pass the floor to Fantina,
Thank you.
and then I will come again. I will take the floor again in the last part of the presentation.
So thank you also from my side for the invitation to this nice conference. We want to show you what we did in the last few years, just to show you what could be something that is really important in this kind of environment. So as we saw from what Francesca was saying, the seafloor geomorphology, so to check how this transitional environment changes over time, it's really crucial. And then I will show you some example of benthic habitat mapping that you can do in these environments. And I will want to show you also some application to detect marine litter and to underwater archaeology. So, sorry, I went back. So first, in 2013, ISMAR did a very extended multi-beam survey of all the channels of the tidal of the lagoon, and we, for the first time, we mapped with a very high resolution some features, some natural features. Some, in this case, we studied 29 scour holes that were found at the tidal channel confluences, and this was something that we could show in different parts of the lagoon, and also it's very interesting to see that you know, in Venice you have also the fact that we have an archive of our historical maps with which we can compare and see how things changes over centuries. So this is also something that's really important to monitor and to understand how these environments evolve over long period of times. So I want to show you also some other features that we mapped in 2013, and then we remapped we monitored also later on. As Francesca was saying, at the inlets, this is one of the inlets, the Lido inlets. They constructed these mobile barriers, and what we could do, we could document the structures, of course, and see really how they changed the seafloor and they changed the inlets to implement the mobile barrier. But also in the south, you see, we studied all the inlets to see how this big infrastructure changed the inlets, and we could document all kind of different features. And you see here, to protect the mobile barriers, at all three inlets, they built a breakwater here, like a sort of semicircular protection barrier. At the beginning of this was built in 2006, and just to protect the inlets from the storms and waves. And we saw that in very few years, in the very few years, this structure, you see that they built here, this barrier, created large scour holes, really, and in 8 years we could estimate that more than 430,000 cubic meter of sediments were eroded. And we could, hypothesize what was going on, because of course the changes of the inlet, you see the inlet of Chioggia here was straight before, they made it narrower, and then they built this new breakwater, and of course they changed the hydrodynamics, and they created new vortices that really eroded the sediments, making also maybe a danger for the structure itself, because it could then with the time fell down. And this thing was observed also in the Lido inlet, and we saw by making repeated surveys, we see how the scour from 2011 to 2016, how they became much bigger. So there is a need also for the coastal infrastructure. There is a need of repeated surveys. So that's what also, robotic solution could be very useful to, send this periodically, this kind of solution to map some areas that we know are highly dynamic. They change very much, and so it's important to monitoring them very, very often. So as a result also of this analysis, we analyzed all the data that I was telling you. This is all the area in blue, all the area that we explored. As Francesca was saying, we could go just on the navigational channels because they are deeper than the shallow water. That's less than 1 meter, so it's difficult to reach with the boat, and also it's a bit difficult to use a multi-beam with 1 meter depth, because of course the multi-beam covers maybe 3-4 times the depth, so you would need a lot of time with the boat to cover the full area. So this is also something that could be very important instead to be done with something robotic that you send, and instead of going with a full team in a boat for months and months. You have to think that just to do the channels range, the depth of the channels, as Francesca was saying, ranges from 2 meters to about 20 meters. So the multi-beam covers much more. But to do all this, it took 6 months of survey with 20 people involved, taking turns, and it was really a big effort. So a robotic solution for this would be, very, something that we could release from our institute and let it go, and collect the data and come back to be great. So I don't know, it's just just to talk with you. So, but just to show you what kind of issues also we found that nobody observed before, because of course using the high resolution multi-beam data, we could see different type of interaction with the seafloor due to the human activity. For example, Francesca was mentioning before the traffic of the big ships, okay? So the big ships, it's a very big debate in Venice, big cruise ships, should they be there, should not they be there? And now this summer they said, no, they should not go, because up to last year, the ships came through the Lido Inlet, went through here, went in front of Samar Square, and here is their docking station, okay? So now the government has said, okay, stop, they cannot go through this, okay? But they can still go here, so they can go here. This is the main route also of the industrial ship traffic, okay? Because here, all this area is an industrial area where we have oil, refineries and things like that. It's a big industrial pole, but here you have seen the results of that ship traffic. So that they eroded all this part, as Francesca was showing before, in 30 years, more than 100 meters of erosion. So this means that this part of the lagoon that we already observed has been deepening, but deepening means erosion in this case. The traffic of the ships these big ships creates big waves that erodes the shallow waters and change completely, the circulation of the water. We have seen that the big storm in 2019, and here, the island of Pellestrina was really, hit by the storm, because here there is practically a free fetch for wind. So there is no obstacles, no more salt marshes, and so big waves can form if there is a storm. So I think they propose now to change the route, but the ship's crews are not out of the lagoon, and there can still be a problem. I mean, and I think it's important because to tell this to everybody, because you see the news and they tell, okay, the big ships are not going anymore. It's half true, that, I mean, they're not going in front of Samar Square, but they're coming from the back door. And you can see also other type of effects. For example, we saw the propellers of the evaporators of the water buses that go into Venice, when they stop the anchor at the bus stops, so to say, they create also big holes. This is a city center of Venice. They create big scours, and also this could be a problem for the stability of the palaces. So why I'm talking about this? I mean, you think, okay, I'm Venetian, but I think Venice is, is a world cultural heritage, and I think everybody needs to know this, because it's not a matter just for the Venetian, it's a matter for, for everybody. So, okay, sorry, I keep going back. But I just want to tell you another application that you can have with this sort of sensors, like multi-beam, for example. This is a channel, a natural channel in the Northern Lagoon. This is Canello channel, and you see this is a high-resolution image, a DTM with 5 centimeters of horizontal resolution. And so and this is really very shallow. You can see we arrive at about 0.5 meters, and you see we stopped here at this because the boat couldn't go further, so we couldn't monitor it further. We couldn't reach. So this is, as I said, an important issue. If you could have a robotic solution that can go, also in very shallow water, this would be very helpful. So you are when you collect multi-beam data, you collect also backscatter data. So the sound wave hits the floor, and the intensity, you register the intensity of the reflected sound wave, and of course the intensity, the reflectivity of the seafloor gives you an information about the habitat, the benthic habitat, the substrate that you more than habitat, because if I say habitat, the biologists always kill me, the substrate that you have in this area. So normally in this grayscale, the darker color correspond to softer substrate, whereas the white, so the brighter color correspond to a harder substrate. And you see, when we collected the data the first time, we saw a very peculiar signal, because we saw these images. You see that there are little black spots here, and we were wondering what they were, because we never explored that area. And you must know that also the biologists did not explore the tidal channels up to recent. So there was no data about the tidal channels at all, about the benthic habitat of this environment. So we went to see with our colleagues, with our biologist colleagues, what these spots, these black spots were, and we found huge demosponge that we didn't know exist in the Venice Lagoon before. So they were really gigantic, more than 1 meter of diameter. So this is something that you could also see, and you see also here the visibility of what Francesca was talking before, that these environments, since they are muddy mostly, they are very, very turbid, and so they really pose an issue for optical methods. Even if they're so shallow, you cannot see anything through it. It's much different from here, I would say. And so this is also important, so that if you had systems combined where you have multi-beam but also optical methods that you could release, at the time and collect data. When you see something interesting, you really put the camera, but the camera should arrive. You could have visibility of 0.5 meters, so it should go really in, very close to the seafloor. So as a result of this study, as I said, we proposed we could, really do new benthic habitat maps of this area and discover a new habitat. But we can see other applications of the multi-beam data. Here we applied the same system to map, in this case, submerged aquatic vegetation in another channel of the Northern Lagoon. And here you see, macroalgae or soft bottom, different kind of bottom, where we did an experiment, and where we also saw the limitation, of the system, because you have also to consider that if you just use the seafloor backscatter, you lose information, because if you instead use also the water column of the system, you can see a lot more. For example, here we could really detect the submerged aquatic vegetation in the water column, so we could actually also do an estimate of the biomass related to that. This is also something that would be very, very important to collect this type of data. This is a type of vegetation that we mapped in that. And you can combine then the backscatter data together with the backscatter data of the seafloor, together with the backscatter data of the water column, and have a picture also of the distribution of submerged aquatic vegetation. So this is also something that would be very nice to do also with robotic, with this kind of sensor, with robotic solution. Okay, I just want to say that we also, as we saw that the morphology changes very quickly in this environment, I just want to show you that also benthic habitats can change very quickly in this environment. And this, for example, is a study that we did in the Chioggia Inlet. These are data collected by Multibeam in 2013, and then we collected this, not the same, a smaller area, but in the same place in 2016. And we could actually, comparing the data over time, and collecting, of course, samples, ground truth samples, to see that, because multi-beam are never enough, multi-beam data are never enough. You always need to have, ground truth data, grain size samples, and drop frames, cameras, videos, to see that actually what you see is something that corresponds to interpret the data, the multi-beam data. And so we could actually also document how the habitat changed during the 3 years. So we can also do, so if we had a robotic system that periodically collected the data, we have put in place a workflow also to analyze the data and to detect the changes. So if we had something, we know, okay, there is a particularly high dynamic area, for example, the inlets, we could say, okay, we do a campaign with a robotic system, collect the data, and put on a robotic workflow, a workflow that to analyze the data to see how things changes over time. This is also very important. Okay, but this is not, okay, we did also see other things that we did not expect. We did see that through this data that some parts of the lagoon are covered with macrolither. Okay, so we have, this part is close to the city center, and you see, okay, this is the resolution we can reach with it's a Kongsberg EM2040 dual compact, and you can see tires, and there are hundreds of tires in the lagoon and in the Venice itself, in the city. But why would, I mean, why? We wouldn't expect this, but this is crazy. You think, okay, why there are tires in Venice, there are no cars? Because the boats use the tires as fenders. So they lose, or they throw them away, and they lose them in the water. But hundreds, because, also in the Grand Canal, that was never dredged. So the layers of macrolither stay there, for decades. So what we did, here you see the distribution of litter in the Grand Canal that I was saying. We mapped all these objects that we could see, and we made a map of the density of macrolither distribution in the area that we explored, so in the old tidal channels. And from that, we started what I think it was a really very, very nice project that finished last year. It's the Marginet project, where we mapped, it was mapping and recycling of ghost nets on the seafloor. And so we developed with the, with the multi-beam, we did some experiments to see, really to determine the sinking velocity, not only to map the area where we found the seafloor litter that I was talking before, but we also made an experiment using the water column of the multi-beam to determine the sinking velocity of the net. So you can see in the water column of the multi-beam, you can see the net, and you can see it sinking. We measure this sinking velocity, and we also published the results in the research. We developed research objects, which means that the experiments is, it's open, the data and the routine that we use to analyze the data are open. So because we want to do, we really want to persecute the FAIR data principle, that we want to share the data as much as possible. And what you see here is the results of a simulation that actually Francesca did in the Northern Adriatic Sea, where we release particles, so in this case ghost nets, and we see where they sink. So, and we use these values of sinking velocity we measured to see the distribution, to obtain the distribution of marine litter hotspots in the Northern Adriatic Sea. And you see here the distribution that we compared, qualitatively with the observation data. So, and this is one part of the project. The other part concerned recycling. We don't want to talk about this because it doesn't have, but we will talk after. Francesca will say something about it. The last thing is that fortunately we do not find only, only litter of anthropogenic origin, but we actually documented in one of the channels in the Northern Lagoon an alignment of structures that you can see very small here, an alignment that goes over 1.2 kilometers, and then also a very big structure. This is, you have to see, it's close to the Lido Inlet that we've seen before. And this is a very big structure. It's long, more than 120 meters. We don't know what it is. So it's something that we are going to investigate. We have to see. But it's really also very puzzling because it lies at 8 meters of depth. And also these structures that we know were investigated and excavated in 1985, where they found some Roman so-called basolis, so these kind of stones used to pave roads, together with different kind of amphorae that let us think, mostly the Dressel 6A, let us think that these structures were of Roman, imperial, late imperial time, in Roman times. And we went again with divers in 2020 on another of these structures of the alignment, and we found also there different stones aligned. So it's an hypothesis, and it's nice that there are archaeologists here. I'm not an archaeologist, so maybe it's the wrong hypothesis. So, but it's nice to discuss with you this hypothesis. We thought that these structures were actually part of a large infrastructure that was going from the south of the lagoon, from Chioggia here, and was going. It was for a road going along the littoral to connect this part of the lagoon to Altino. Altino was the ancient Roman city that that was the most important city at the time here. So this is of course object of debate. This had a very unexpected, I must say, word resonance. And let's see if we are right or not. There are other colleagues that think we are not right, but you know.
and I would like to mention that there is the issue of the sea level rise.
Yes.
Sea level rise, because the constructions were at 4 meters, but at that time, the sea level rise in this area should be 2 meters. So
it's I mean it's a very challenging, but it's something that, you know, in the Venice, what I want to stress also for the robotic people is that this area has a lot of Roman settlements, a lot of them, but few of them are really very detailed, documented, excavated, mapped. So I think this could be really a very important application for very shallow robotic solutions, because you know, we cannot go with the boat in some parts, and this, as I said, these structures are normally at 2 meters or, you know, maximum, or here we have 4 meters. We don't know why, but you know, this is needs to be investigated by, you know, robots, I think, you know, more than boats and people. So robots or you know, divers that we were talking about yesterday, with because some of these sites are submerged, but you know, we mapped the submerged part, of course, but for sure there are things that are buried. We know this. So this also sub-bottom profilers would be important. So I let finish Francesca.
Yes, yes. So you saw a lot of applications, and now I would like to very quickly go through some projects that used some robotic solution on these kind of applications. So the first one is the Innova Project that probably you saw in the BTS program, because tomorrow it would be presented in the details. So I would like only to mention that within this project we are building 2 vehicles together with our colleagues in the Institute of Maritime Engineering of the CNR, and we are equipped, and this kind of vehicle will be explained better tomorrow. The important thing is also that we have a lot of sensors there, and we would like to test also the artificial intelligence, the camera with artificial intelligence software connected, and then also the multi-beam and radiometers, and the use also of nutrient analyzers. So
can I add this? Yeah, because we want also to use, there are other projects, we didn't talk about this, but we want to use also satellite data.
Yeah,
I mean,
of course.
This is not only multi-beam, but of course all these kind of sensors collect data that can be very useful for satellite observations.
Also for the submerged aquatic vegetation,
yes,
or for the bathymetry from satellite. So there are many other applications. So another project, I will go very quickly because I think we are late, and is the Milestone project. It's an H 2020, and in this project we have a very nice new platform that will be built by Technalia.
We don't have it yet.
But we will have, I think.
It's in the design phase.
I'm confident that we will have. And in this platform we have a robot that will have suck the litter, the very small litter from the seabed, and then we have also a hook and also an arm with grip.
So in principle, you have a floating platform that you see there in gray,
yes,
and in the middle you have this little cube that is the cable robot. The cable robot has different instruments attached, a suction or a grip, a suction tube or a gripper or a hook, depending on the kind of
typology, yes,
on the kind of elements that you want to macro liter that you want to collect.
And then this macro liter will be put on the platform, and there we will have artificial intelligence based sorting robot to sort this kind of marine litter and then to recycle it, because we didn't mention a lot of this part, but we in Marginet project, we tested a very nice prototype to recycle the marine litter without pre-processing, so without pre-cleaning, and transforming this marine litter, dirty, directly in fuel. So this was a very, very nice experiment. And the Maelstrom is the continuation of this experience. So then we have, we would like to mention only this robotic solution for the deep water. This is an AUV, and we have also an USV connected with it. This is Endurance project. The project is also an H2020. And the point here is that within this project we are developing a new software for adaptive emissions, also usable for coastal areas. So
to use multi-beam.
Yes, so this kind of software can be also then applied to other, not only for the deep water solution, but also for the shallow ones. And I would like to go very, very quickly to the bigger picture, because I would like to mention that Venice, but also here in Croatia, this place, and many places along the Adriatic Sea can be a very nice test bed for this kind of solution because of their features. And European Commission established this European Forum for Research Infrastructures. CERN is one of them. So we have different topics, so the environmental one, the physics one, and so on, the social one, and so on. But through this kind of bigger research infrastructure, we can share data and also test our technologies. So sharing also the results and so on. So I would like to mention an example connected with the transitional environments. This is Danubius. Danubius is the International Center of Advanced Studies for River Sea Systems. I will go very quickly because we don't have time. So I will show you only the fact that Danubius involved the major river sea system of Europe, and we have also the North Adriatic Sea in this context. Through this kind of infrastructure connected with the local project, so for example the Innova project, we can share the research data, collaborate to innovate also from technological point of view, and also to have technological transfer. So Innova is one of these projects his aim is to create the innovation ecosystem within the Adriatic Sea, and so we would have at the end a better environmental management. So the take-home message is that the robotic solutions are needed in order to have an ecosystem-based management of the transitional coastal areas, and so the Venice Lagoon can be an ideal natural living lab for that, for the reasons that you already saw. And so come to visit us in Venice and help us to go ahead with that. Yeah, with this. We have this very nice facility because, as you can see, we have this pool. Let's say.
Let's come and test the robotic solution in Venice.
So thank you for your attention, and yes.
Thank you very much. Excellent presentation. We have a short time for questions.
Thank you, amazing work. I mean, I knew part of it, but now it's really, really nice to see all of it. Did you ever work on specifically the impact of the ship cruises, like checking in the floor if there's litter from the cruises, or like a systematic approach of monitoring the impact of the cruises in Venice?
Yes, I mean, as I showed you before, we documented that, you know, there is erosion. You can see it from the multi-beam. I can show you after the picture where you can see really the erosion of the seafloor. And there are our colleagues in CNR-ISMAR that are studying this for years now. They collect ADCP data, turbidity data, as you saw, satellite data, where they really documented the erosion created by the ships, and they also related this to the velocity of the ships. So they are really, I mean, if they go slower, you reduce the impact, of course, so we have to be very careful that this kind of it's a very fragile ecosystem, the lagoon. So you need really to take into account also this kind of data to make decisions about the management of the area.
We didn't mention the effect of the Mose barrier, because we have a lot of hydrodynamics modeling studies on that. So we have a lot on it also, but not in this.
Yeah, thank you for this presentation. Just a rapid question. Did you investigate also aerial solution for shallow water?
Sorry?
With drones, aerial drones for shallow water.
Yes. Okay, so, sorry, yeah, I didn't put this in the presentation. That's a very nice question, thank you. In fact, we have a monitoring program that lasted the last 3 years. It's called Venice 2021. And within that, we monitored, since we have this problem of erosion of salt marshes, we monitored salt marshes and channels, and we actually combined the data. So we use, in fact, all the part of this, we use an aerial drone and combine this data with the multi-beam data. We didn't publish yet the results because we are, we did this year the second monitor this last summer. But it's a process. It's ongoing. We combine the two. Yes, of course, aerial drones are really important. Yeah.
Okay, thank you. We'll stop here. And Francesca and Fantina, thank you very much.
Thank you very much.